In this video, we are going to look at the different types of data, more specifically, quantitative and qualitative types. Imagine you're on a geography fieldwork trip when you are asked to count the number of cars passing by a point in 30 seconds. The value that we get, let's say 3 cars, is an example of quantitative data. Now, your teacher asks you to note the color of each car that passes by. The color here is an example of qualitative data. So, from these examples, we can determine that quantitative data is any numerical observation or measurement, and the examples that we said earlier, including the time of 30 seconds, are all valid examples of quantitative data. By contrast, qualitative data can be defined as any non-numerical observation, as in our case, we confirm the color, for example, a blue car, was qualitative. One more term that we will cover is raw data, which is any data you have collected but not yet processed. Examples of processing data includes ordering, rounding, or grouping data. So raw data is basically when you haven't done the following to your data. These terms are all part of the GCSE Edexcel specification, so make sure you understand what they refer to. Now, you may struggle to differ between the two terms, so one way of remembering this could be the prefix quant, which resembles quantity. This is a numerical value, as quantitative suggests. Qualitative data, on the other hand, contains the partial word lit, short for literature. However, I prefer to remember the first of the two, and then that as they are contrasting to each other, qualitative must be non-numerical. So we have taken a look at what quantitative data is, and now we are going to look at how we can further break this down. Quantitative data can be broken into 2 types, continuous and discrete. Anything that is continuous is data that can take any value on a numerical scale. Examples of continuous data could be mass, length, or time. Some examples of these are shown below. On the other hand, we have discrete data, which is data that can only take particular values on the numerical scale. These examples that we have here, shoe size and the number of siblings, both represent discrete data, and they highlight one key thing. A discrete value is not always necessarily an integer value. As we see here, shoe size is discrete but is a decimal. This is because it can only take a definite number of values. Your shoe size isn't 3.52134, but rather it is a whole number of 3.5 or 4.5. This is what it means by only particular values. Now, the definition of continuous data doesn't quite serve an explanation of what it actually means, so the best way to demonstrate this is by using an example of someone's height. Let's say 150 centimeters. I can measure this height further into more precision in millimeters and get the height as 150.1 centimeters. If I keep going into more detail, it becomes 150.15 centimeters, and even further precision, it becomes 150.157 centimeters, and so on, etc., etc. The point of this is to show for certain units of measure, we can go infinitely precise. If I really wanted to, I could record the height of each individual atom, if it were possible, and still be able to record further. Another way of thinking about it, you may leave school at 3 o'clock, but it's not exactly at 3, is it? You could leave a couple of seconds late, and even then, on the milliseconds, nanoseconds, the list goes on. Hopefully, you now have a better understanding of the concept of the 2 data types. Now, let's do an exam question. Take a minute to have a go, then check your answer. We are given 4 terms that we have just covered, and we are asked to choose the appropriate data type for each case. Now, you should note this question is entirely made up by me, and so it's quite open-ended in terms of allocation of marks. Some questions have more than one correct answer, and this is for the purpose of this video. Do note though that in the exam, the questions will be designed to have only one right answer, and this is just to understand the content. So, looking at the number of pets owned, the first keyword, number, instantly makes you think quantitative, as we saw at the beginning with the definition. Bearing in mind the question says that there could be more than one right answer, we need to take a look at the rest of the words given. We have just stated that it is quantitative data, and so by definition, this means it cannot be qualitative data. Now it has to be either of the last two words. So we need to look at this holistically. It can only be one of the two, discrete or continuous. So if you do, how many pets do you have? Chances are you are thinking of a whole number. So from this, we can be sure that this is an example of discrete data. For part B, your favorite type of pet is not a number unless you're Elon Musk. So based on this and looking at the words given, it must be an example of qualitative data. For the next question, we are given a table and a statement. The table has 4 students, A to D, and 2 more columns with their favorite sports and their ages. The student having seen the data says, favorite sports is quantitative. Explain why the student is wrong. Again, this is a question I made up, so it could easily be a 1 marker for its nature, but I have made it 2 because of the command word, explain. I have copied the table over here so we can look at it in more detail. The column, favorite sports, as shown here, contains football, basketball, and tennis as the sports. We know that these are not numbers, so we can say that because they are categories, which will earn you a mark, this is in fact qualitative data, and that gives you the 2 marks. So we have seen how we can break down quantitative data, and now we would look at the subcategories of qualitative data. Qualitative data can be broken into something called categorical data, which we can define as data with non-overlapping categories. We can understand this using the example of your eye color or your pet. You can only have one color for an eye, so as the color represents a category rather than a numerical measurement, it is categorical data. The same applies to your pet if you have one, which can only be one animal type and not a quantity. Some categorical data can be further split into what we call ordinal data. This applies to data with ranking or order or numerical scale. Again, this is another concept best explained with an example. Suppose you wanted to give a rating of how clean your local parks are. The survey, if that's what it is, could ask in many ways and still be ordinal data. They could ask something like this. On a scale of 1 to 5, with 5 the best, how well does the local council deal with rubbish in parks? Or they could give you a view, and you could be asked to choose whether you strongly agree or disagree, etc., etc. Although it doesn't seem to be ranked, the quantifiable measure is still there. For example, strongly agree is higher up than agree, and so on. Do note that just because you see some numbers, it isn't necessarily quantitative data. The ranking part here is still qualitative due to the actual data behind the numbers, in our case the cleanliness of the parks. Looking at an exam question, we are asked to pair the 2 terms to the right scenario. Pause the video and take a minute to answer the questions. Now, for the first part, favorite type of music, we can determine that most types of music are not numerical rankings, so this must be an example of categorical data. Your favorite type of music can only be a single type. For part B, the level of satisfaction of school food can be thought of, for example, as bad, okay, or good. You can be more specific if you wish. The point being is that good is better than okay, and okay is better than bad. This means they are distinguishable so they can be ranked. Therefore, this is an example of ordinal data. Thank you for watching this video. If you found it useful, hit the like button, share it to someone, and subscribe to the channel. There are also some worksheets available in the video's description. Any questions can be left in the comments section below. Hopefully this video has meant you know a little more about the types of data.